Hello friends, Mr. Burrell here. We are in this lesson talking about factoring and finding all zeros. So far in this unit we have talked about / reviewed how to solve quadratic equations. We've talked about factoring and we've talked about the quadratic formula as methods we can solve quadratic functions, okay? Then we started talking about larger polynomial functions, higher degree polynomial functions, cubic, quartic functions, and how we deal with those. We've talked about something called long division as a method for dividing two polynomials in order to make one of these larger polynomials a little bit smaller and maybe more manageable, more easy to deal with, okay? So that's what we're going to start talking about in this lesson is now we're going to get back to solving polynomial equations, finding the zeros of polynomial functions using factoring and polynomial long division. Okay, so the problem here says if I am given at least one solution, I can find the other solutions through long division. Okay, so we have f of x equals x cubed plus 7x squared plus 2x minus 40. We've learned in previous units that since this is a cubic function, that means I'm going to have three solutions. Whether they're real or imaginary, I don't know yet, but I'm going to have three solutions. And conveniently here, I am already given one of those solutions. I know that one of the solutions to this function, one of the zeros, is x equals 2, okay? So as of this very moment, we don't know how to solve this equation. I don't know how to find the zeros, okay? And that mostly comes from the fact that all the methods that we know for solving polynomial functions have to do with quadratics. And this is not a quadratic, this is a cubic. So what we're going to talk about in this lesson is how can I break this polynomial down into one that's a little bit smaller, say a quadratic that I do know how to solve, okay? So what I'm going to do in order to do that is I'm going to use some long division, okay? So we recently just talked about how if I have two polynomials, one bigger, one kind of smaller, a dividend and a divisor, I can divide them in order to break this polynomial down into one that's smaller. This one right here down into one that's smaller. You might remember we put, excuse me, this larger polynomial underneath the division bar. We had x cubed plus 7x squared plus 2x minus 40. And then we had a divisor out in front. Notice right here, I am given one solution, x equals 2. That is not a polynomial. That's like a solution from a polynomial. Okay, so I'm not just going to like put x equals 2 out here. That's not going to make sense. Rather, let's consider what polynomial I would have started with that would give me this solution, this zero, this root, okay? Well, notice if I were to go ahead and subtract 2 on both sides, I would get x minus 2 equals 0. That hopefully looks kind of familiar. Sometimes when we're factoring and we have like x plus 4 times x minus 2 or something, I'm trying to find the zeros. I set each of those factors equal to 0. So this right here, x minus 2, is the factor that I would have originally started with that gave me the solution x equals 2. So that is what I'm going to put out here in front of the division bar. Okay, x minus 2 divided into x cubed plus 7x squared plus 2x minus 40. Okay. Now let's do some long division. We just finished talking about how to do this. So let's see. How many times does x divide into x cubed? Well, that's going to give me x squared. Okay, then I'm going to multiply x squared by both of these terms. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. Okay, I'm going to go ahead and change these signs. I'm going to start changing colors too. So I'm going to change these signs in order to subtract x cubed minus 2x squared from the original polynomial. X cubed minus x cubed is 0. We like that. That's good. And 7x squared minus a negative 2x squared or plus 2x squared is 9x squared. I'm going to go ahead and bring down this next term, and I'm going to start over again, right? How many times is x divided into 9x squared? Well, that's going to give me 9x. Okay, then I'm going to go ahead and multiply 9x by both of these. 9x times x is 9x squared. 9x times negative 2 is negative 18x. I'm going to go ahead and subtract or change the signs. I'm going to do that with a new color. 9x squared minus 9x squared is 0. Love that for us. 2x plus 18x is 20x. I'm going to bring down the next term, which gives me negative 40. And I'm going to start over again. Okay, so how many times does x divide into 20x? Well, that's going to give me a positive 20. Okay, I'm going to do 20 times x and 20 times negative 2, which gives me 20x minus 40. This looks kind of nice. So when I subtract this last polynomial here, I'm going to change the signs. 20x minus 20x is 0. Negative 40 plus 40 is 0. I like both of those. Okay, I went through those long division steps kind of quickly. If you need a stronger refresher on long division, go back and watch the last video. But those two polynomials divided perfectly. X squared plus 9x plus 90 is plus 20 is my result. Okay, that's great. So really, I could rewrite this polynomial. Okay, this might look a little bit different, but I could rewrite this polynomial right here as, let me write it over here, x minus 2 times x squared plus 9x plus 20. Okay, and because I'm a skeptic, as a way to double check my work, if I multiplied these back together, right, I should get x cubed plus 7x squared plus 2x minus 40. Okay, that's great. That's not technically new information. But remember, now what this problem is asking us to do is to solve. I'm trying to find all the solutions to this polynomial through long division, all the zeros. Okay, so in order to find the zeros, I'm going to go ahead and set this function equal to 0. Okay, and I can already set x minus 2 equal to 0 and get a solution of x equals positive 2. I already have that solution. That's fine. Now I would need to solve this polynomial, this equation. I would need to set that equal to 0. Well, notice now that I've divided, this is a quadratic equation. I know how to solve quadratic equations. Okay, so I'm going to go ahead and factor this quadratic equation. Okay, so in order to do that, I'm going to need to find two numbers that multiply to make 20 and add up to 9. That's going to be 5 and 4. Okay, so let me rewrite my little polynomial here. I have the x minus 2 that's been here all along. I'm going to go ahead and write x plus 5 times x plus 4. So now notice I have 3 factors, meaning I'm going to have 3 solutions, which is how many I was supposed to have from the very beginning, right? I already set this factor equal to 0. X minus 2 equals 0 gave me x equals positive 2. If I set x plus 5 and x plus 4 equal to 0, and subtract 4 on both sides, subtract 5 on both sides, I'm going to get x equals negative 5 and x equals negative 4 as my other 2 solutions. Okay, so let me come back up here. My 3 solutions are x equals 2, which I was given, x equals negative 5, and x equals negative 4 that I found after doing long division and then solving the resulting quadratic equation. Okay, that's what we're doing in this lesson. We're not doing anything new. We're meshing what we know, what we just recently learned about long division, and what we know about solving quadratics together in order to solve some of these larger degree polynomials. Okay, let's do another example. We're going to do some unique examples. Here I have f of x equals x cubed minus 7x minus 6. And I'm given one solution, it's x equals 3. So I'm going to go ahead and divide. Okay, and instead of x equals 3 here, I'm going to write x minus 3 because that's the factor, that's the divisor that would yield a solution of x equals 3. Okay, so I have x cubed minus 7x minus 6. You might notice that this looks a little bit smaller maybe than the previous cubic polynomial. This cubic polynomial had 4 terms. This one has 3. You might notice that there's a term missing. So remember, when I'm doing long division and there is a term missing, in this case there should be an x squared term here, but the coefficient is just 0. I'm going to put a 0 placeholder where that term is missing. So I'm going to go ahead and divide x minus 3 into x cubed plus 0x squared minus 7x minus 6. This is going to make sure I don't make any mistakes, okay? So let me go through this long division. I'm going to do it relatively quickly. How many times does x go into x cubed? That's going to give me x squared. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. Okay? I'm going to go ahead and change the signs. I'm going to subtract here. X cubed minus x cubed is 0. Love that. 0x squared plus 3x squared is 3x squared. Love that. I'm going to bring down the negative 7x and start over. How many times does x go into 3x squared? Well, that's going to give me a positive 3x. 3x times x and 3x times negative 3 is going to give me 3x squared minus 9x. And then I'm going to subtract or change the signs. Boop, boop. 3x squared minus 3x squared is 0. I love that. Negative 7x plus 9x is 2x. We'll go ahead and bring down this negative 6 and start over. How many times does x divide into 2x? Well, it's going to give me a 2. Okay? 2 times x and 2 times negative 3 is going to give me 2x minus 6. You're noticing that this looks really nice. I'm not going to have any remainder because when I subtract or change the signs here, 2x minus 2x is 0. Love that. Negative 6 plus 6 is also 0. Love that even more. Okay? So I don't have a remainder. When I divide those two polynomials, I'm left with x squared plus 3x plus 2. Something to note here. If I get a remainder on a problem like this, I cannot solve it using my methods with quadratics and other things, okay? So on these problems that I give you, if you get a remainder, you've done something wrong with your long division. You need to go back and check your work here, okay? But now that I've done my long division, this polynomial, x cubed minus 7x minus x, 6, could be written as x minus 3 times x squared plus 3x plus 2. Okay, I've kind of broken it down. I've factored it a little bit so far. And I'm tasked with finding the zeros, finding the solutions. Well, I already have the solution from this factor here, x minus 3. I set that equal to 0. I get x equals 3. Now I'm going to solve this quadratic by factoring. Okay, so I need, and again, the reason I know it's a quadratic is because it's squared here. I need to find two numbers that multiply to make 2 and add up to 3. Okay? Well, the two numbers that multiply to make 2 and add up to 3 are 2 and 1. So I'm going to go ahead and write x minus 3. And then x squared plus 3x plus 2 becomes x plus 2 times x plus 1. Okay? Well, when I set each of those factors equal to 0, x plus 2 equal to 0, x plus 1 equal to 0, we already did x minus 3 equal to 0, but we'll write it again, down again just in case. I end up with solutions of x equals 3, which I already had, x equals negative 2, which I just found, and x equals negative 1. Those are my three solutions. I already found x equals 3, so I'm just writing it again here as a courtesy, basically. And my other two solutions are negative 2 and negative 1. Okay, so a little bit different on that problem because I had to put in that 0 placeholder, but same process. Really nothing new here. I'm doing long division, and then after I do long division and get a quadratic function, I use factoring, or technically you could use the quadratic formula to solve that resulting polynomial. Okay? Let's take a look at another one. This one maybe looks a little bit more difficult because I have coefficients in front of every term, including this first one, but let's get after it. Okay, there's no missing terms, so I'm going to go ahead and write 2x cubed minus 6x squared minus 8x plus 24 underneath here. And x equals 3 is my solution, so just like the previous example, I'm going to divide x minus 3 into this polynomial, because that's the divisor that x equals 3 would have come from. So I'm going to go through the long division relatively quickly. X goes into 2x cubed and gives me 2x squared. Multiply 2x squared by x minus 3, I get 2x cubed minus 6x squared. I'm going to go ahead and subtract or change the signs. I'm going to get negative 6x squared plus 6x squared, which is 0 a couple times. That is very interesting. Okay. So now I'm going to go ahead, since both of those terms disappeared, I'm going to bring down the next two terms, minus 8x and a positive 24, and I'm going to divide x minus 3 into that. I'm going to start over. That was a little unique. I haven't had a lot of situations where both of these first terms disappear when I'm subtracting, okay? So let's see. Does x divide into negative 8x? Yes, that's going to give me negative 8. Notice I'm going to write the negative 8 above the other constant over here so I don't get anything messed up. Negative 8 times x minus 3 gives me negative 8x, and then negative 8 times negative 3 is positive 24. Okay, this is going to factor out nicely again for me because if I subtract / change the signs, I end up with zeros again. Okay, there's a little smiley face to remind you of how you're supposed to feel today. Okay, so this looks a little bit unique. So when I divided these polynomials, ended up with x minus 3 times 2x squared minus 8 equals 0. Again, that looks a little bit different. But note, again, this resulting polynomial here is a quadratic because we have the x squared here. So I can use my traditional factoring methods or the quadratic formula to solve this. So let's take a look at 2x squared minus 8. Okay? If I'm going to try to set that equal to 0, first of all, let me note that I can take out a greatest common factor. Both of these terms are divisible by 2, so let me rewrite this as 2 times, in parentheses, x squared minus 4 equals 0. Okay? Note also that I could have, at the very beginning of this problem, taken out a greatest common factor of 2. It doesn't matter where I take out the greatest common factor of 2. I'm doing it now. I could have done it at the very beginning. So now this is the quadratic I need to factor. Okay? This one looks a little bit funny again, but you've seen something like this. This is really just x squared plus 0x minus 4, meaning that I need to find two numbers that multiply to make negative 4 and add up to 0, which are 2 and negative 2. Okay? So that's going to leave me with x plus 2 and x minus 2. I also had the x minus 3 from earlier, and the 2 that I took out as a greatest common factor. Doesn't matter where the 2 goes, but there it is. Okay? There's my completely factored polynomial. I started with long division to break it down a little bit more. Now I have my completely factored polynomial. Well, I already know what the solution is here, x minus 3. When I set that equal to 0, I got x equals 3. My other two solutions are going to be, if I set x plus 2 equal to 0 and x minus 2 equal to 0, I'm going to get negative 2 and positive 2 as my other two solutions. Okay? So a little bit different there, but still, again, the same process, the exact same points that I need to follow. I used long division, broke it down until I have a quadratic, which I could then solve by factoring. Okay? Let's do one more example. Okay? Right here I have f of x equals x to the fourth minus 8x cubed plus 22x squared minus 20x. I'm asked to find all the solutions where this one solution is already given to me, x equals 2. Okay? Right off the bat, the difference between this problem and some of the previous ones is this is a quartic function. This is x to the fourth. Okay? So I can go about this basically the same way. Notice something about this problem. I have a greatest common factor. Okay? In the previous example, we mentioned we could take the greatest common factor out right here at the very beginning or later after I did long division. On this problem, let's take a greatest common factor out first. This problem has a greatest common factor of x. If I take out a greatest common factor of x, I'm left with x to the third minus 8x squared plus 22x minus 20. Okay? So this polynomial is what I'm going to use for my division. So I have the solution x equals 2, so I'm going to write x minus 2 and divide that into, I'm going to need more room than that, x minus 2 divided into x cubed minus 8x squared plus 22x minus 20. Okay, so I'm going to go ahead and do this long division right here. So again, I'm going to go through this relatively quickly. Does x divide into x cubed? Yes, gives me x squared. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. I'm going to go ahead and subtract or change the signs here. X cubed minus x cubed is 0. Love that for us. Negative 8x squared plus 2x squared is negative 6x squared. Go ahead and bring down the 22x and start over again. Does x divide into negative 6x squared? Yes, it gives me negative 6x. Negative 6x times x is negative 6x squared. Negative 6x times negative 2 is a positive 12x. Okay? So then I'm going to go ahead and subtract or change the signs. Oops, here we go. So I'm going to change this to a plus, this to a minus. This is 0, which I like. 22x minus 12x is 10x. Okay? Gonna bring down the negative 20 and start over again. Does x divide into 10x? Yes, 10 times. 10 times x is 10x. 10 times negative 2 is negative 20. That's a good sign. Means I'm probably on the right track because when I subtract this, 10x minus 10x is 0. Negative 20 plus 20 is also 0. That is a good sign. This divides evenly. So that's my resulting polynomial. Okay? So let me write out x minus 2, because that's the factor that I would have gotten to get that solution up there, times x squared minus 6x plus 10 equals 0. Okay? Does that look okay? I am missing something. Okay? What am I missing? Well, at the very beginning, I took out a greatest common factor of x, So that greatest common factor is still here. It hasn't gone anywhere, right? So I have x times x minus 2 times x squared minus 6x plus 10. Reminder, how many solutions are we looking for? We need 4 total solutions, including the x equals 2 that I was given. Okay? Well, I'm going to have to factor this quadratic. Okay? So if I go ahead and find 2 numbers that multiply to make 10 and add up to -6, what do you notice? Okay, what do you notice? Well, I can't factor x squared minus 6x plus 10, right? What am I supposed to do if I can't factor? Well, I'm going to have to use the quadratic formula, okay? So the quadratic formula states that x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. There's the quadratic formula. Hope you enjoyed that. Where this is a, which is going to be 1 in this case, b, and c. So the quadratic formula states that my solutions from this term right here are going to be -b, so -6, plus or minus the square root of b squared, -6 squared, minus 4 times a, which is 1, times c, which is 10, all over 2 times a, which is 2 times 1. Okay? I'll simplify this down a little bit. You could type this into your calculator and get like a decimal, but that's going to be 6 plus or minus the square root of, inside the square root here, which remember we call the determinant, is 36 minus 40, okay, which is going to give me -4, which then is going to translate into an imaginary solution, okay? So remember, this negative is going to come out of the square root as an I. So my final answers are going to be x equals 2. I'm going to have x equals 6 plus, and then the square root of 4 is 2, so it's going to be 2i over 2. I'm going to get x equals 6 minus 2i over 2. But that's only 3 solutions. What am I missing? I solved this, solved this. This x out in front, when I set it equal to 0, is going to give me solutions of x equals 0. Okay? So those are my 4 solutions. Okay? I think that's the last example we're going to do. So there you have it. If I have a polynomial bigger than a quadratic, like a cubic or a quartic, and I'm given one of the solutions, I can use long division in an effort to solve that polynomial by breaking it down into a quadratic that I can then either factor or use the quadratic formula to solve. So I hope that was helpful. Please let me know if you have any questions, and I hope you had as much fun as I did.